What we're up to today. Let's get some stuff going here. Today's what? August 22nd. Is this notes number 4? I think. All right. So this will be one of those where we've got basically going to stick with systems for a few days, and we're going to do a bunch of different things. We're going to solve them one way, solve them a different way, solve them by graphing. We're going to do some inequalities. So it's a little bit of a mix of some things we've kind of gone through with solving, but kind of mixing in some stuff. So when we're talking about solving systems, first thing is of what a system looks like. Is something like this, where you've got two equations that are together, and they just put the brackets here at the end just to kind of tell you that they're teamed up together. Later on, we'll actually get to one. After we've kind of practiced on the two, we're going to go to the 3 equation system, but that's still a few days down the road when we get there. So. Usually it's on the left. So. Yeah. Okay, so here's what we're going to do. We've got a couple of different ways we're going to do this one. So we'll look at the first option first. To solve a system, by elimination. And sometimes instead of calling it elimination, sometimes they will call it the addition method. Every book is a little different. Every book is a little. Sometimes they'll say elimination method. Sometimes they say addition method. It's the same way way that you go here. So here's why it's the addition or the elimination method. You add equations together. To eliminate, and there's why it's one of those two options, because you're either going to add equations together, but at the same time, when you add the equations together, you're going to eliminate one of the variables. Okay, so now most all the equations we've done up to this point, we've had one variable. Now we've got 2 variables. So we're trying to get rid of one variable so that we've only got one variable left, because an equation is to get the first one, you have to be able to get rid of one equation, one variable, so you can get to the second one to figure out what's happening with it. Okay, so once you do that, then after you've eliminated one of the variables, you're going to go ahead and solve whatever variable you have left over. And after finding the value of the first variable that's left, so we had x and we had y. Let's say we eliminate the y. Now we're going to solve for x, because that's usually the first thing that we do. We've eliminated y. We've got the x variable that's left over, so we're going to solve it, figure out what that value of it's going to be. You're going to plug that value into any of the equations. To find the value of the other variable. Okay, now here's the big thing. Sometimes we do this and people are like, all right, I understand what's going on. Sometimes people want to know what you're looking for. Here's the key thing that you're looking for this part. You want the same number or say number, coefficient really, but you want the same number on the same variable in both equations. We'll do a colon, semicolon, not really sure which one it is there. We'll pause. Where one number is negative and one number is positive. Okay, so that's really the key thing you're trying to do here in this case. You're trying to rearrange the equations and make them work out so that you've got 4x and negative 4x. You've got 10y and negative 10y. You want it so that you've got the same numbers on the same variables, but one number is going to be positive and one number is going to be negative. And we'll talk about this more in just a minute, but you can multiply, you can move things around, you can do all kinds of stuff to make it so that you can get those two things to line up. So, all right, so let's do this. Let's go back to this sample that we had back up here, and we're going to solve this one. And most of the time the directions are just going to say that. They're just going to say solve the system. So we got negative 2x plus 8y equals negative 8. And then 5x minus 8y equals 20. Okay. And then going back to Emma's comment a minute ago, when we're doing this, a lot of times they're going to have the bracket on the left, especially when we get to when we start doing the three equations. A lot of times on the end, if I'm writing these out, I'm going to put like an E1 and an E2 over here. So know that if we start talking about this, especially in class, I'm going to say, all right, are you talking about, in this case, it's a little easier because I'm going to say, are you talking about the top equation or the bottom equation? When we start doing stuff with three, it's a little bit easier to say it's equation 1, 2, or 3. So I'm just going to go ahead and kind of label this over here so that we know exactly what's happening when we get to the next examples we go through. Okay, so for solving one like this, again, the key thing we want is we want the same number, same variable. One's going to be negative, one's going to be positive. And you have that right here, right? That you've got plus 8 minus 8. And if that's the case, you just add the two equations together. So it's negative 2x plus 5x, which is 3x. 8 minus 8 is 0, which, again, if you do 0 times y, that's just 0, so that's gone. And then negative 8 plus 20, or 20 minus 8, is 12. Okay, now, how easy is that equation to solve? Pretty easy, right? Because now you're just taking both sides and dividing it by 3. So we get x equals 4. Okay, now here's the thing when we're doing these. And if it's on Math Excel, it's a little bit easier because when we're going through Math Excel, every single one of these problems, they're either going to go ahead and have an x equals and a y equals to kind of clue you in. Either that or they're going to go ahead and give you an ordered pair, and you got to go back and fill in the ordered pairs. So they'll kind of give you both of those. So once you've got the x equals 4, now you're just going to take this value, and you're going to pick either one of these two equations. Doesn't matter which one, just the one you think is the easiest. We're going to take that x equals 4, plug it back in, and then we're going to solve that equation. All right, so let's just plug it into equation 1. Okay, again, there's no right or wrong equation to plug it into, whether you pick 1 or 2. I'm just picking 1 just because It might be easier, maybe, maybe not. All right, so we're going to plug in the 4 here for x. So we got that. All right, I'm running room here at the bottom, so I'm just going to put this answer over here. So we've got negative 8 plus 8y equals negative 8. Question?
So that's gonna, once you add to the other side, it's not gonna be 0.
It is, yeah. Let me just put this underneath. It might make it a little more sense here. So we got negative 8 plus 8y equals negative 8. Yeah, so we're going to add 8 here and add 8 here. So that's an 8y equals 0. But if you divide by 8, 8's cancel. You still get y equals 0, which is okay. Okay, so if it's an ordered pair answer, that is 4, 0. And that's one of those sometimes you just have to read through the question because I think even some of the last test questions, sometimes it was write your answer as an ordered pair. So you had to go back and do that. But again, with Math Excel, a lot of times they're just going to give you an x equals and a y equals. If they give you those 2 blanks, then you just fill in the 2 numbers and you're good to go there. Okay, now here's what we're going to get to tomorrow. I always like to show this part of it first. What this actually is, if you go back and do this, is we're going to graph these 2 lines. And so what this thing is doing is this is telling us where these 2 lines cross. So if we were to graph this line and this line, they would cross at the point 4, 0. And that's what we're going to look for. But it's easier to see the math first. And then tomorrow we'll show you the graph of it and how it looks because it's just, to me, this seems like it clicks a little better there. So, question?
Why did we plug 4 into the negative 2x plus 8y equals negative 8 equation, not the one underneath the 5x?
Either one's fine. You just have to pick one. But either one you plug it into, you should get 0 for the answer if you plug it back in there. And we can show you that one real quick. If you had picked equation 2, because it was 5x minus 8y equals 20. Yeah, and you don't have to write this down. This is just saying what if you're. If we'd taken x equals 4 and plugged it into this one, it would have been the same answer. Because that would have been 20 minus 8y equals 20. If you subtract 20, you still get 8y equals 0. And we divide by the negative 8, we still would get 0. So in that case, that's one where it doesn't matter which equation you plug it into. You're still going to get the same answer either way. So that was just a what if, So there's why, again, you could pick either equation. Doesn't matter. You should get the same answer either way. As long as your math is good and you don't mess up your math, you should get the same answer either way. Okay, so that was one where everything was perfect. We had a positive 8y, we had a negative 8y. We put them together, and then boom, the math was pretty easy and going back and do what we had to do there. All right, so let's give a what if. Let's change it just a little bit. Let's go with 3x minus 4y equals 12. And then 3x plus 6y equals negative 8. All right, so this time we're close. We've got the right numbers on the 3 on the x. We've got a positive 3x. We've got another positive 3x. We just need to make one of them negative. So if we're going to do that, if we want to say we keep this one positive, we want to make this one negative, all we're going to have to do then is that to change the sign of one of these, we're just going to take this equation and multiply it by negative 1. And here's where we're going to add to this one. We'll show you a little bit more of this on the next one. But you can multiply either or both equations by any, and we always have to do this because sometimes people will say, I'll just use 0. No, you can do that because that's cheating. You multiply by 0. By any non-zero number to help with elimination. And we'll show you more of that here in just a minute, but this is the one that kind of easy to kind of walk into. So if you've got a positive 3 on both of them, and you need one of them to be negative, you're just going to take the entire equation you have and multiply everything in that equation by -1. So that's 3x minus 4y equals 12. And then multiplying everything here by -1, again, you're just going to change the signs. It's going to be -3x, a -6y, and a positive or just a regular 8. Okay, everybody good with that so far? Everybody okay there? All right, and again, if we do that, now we've got a positive 3, -3. Now we can just add it together. 3 minus 3 is 0, x, so that's out, that's gone, because that's just 0 times x is just 0, which doesn't do anything. -4 minus 6 is -10, y, and 12 plus 8 is 20. Okay, and again, from there, pretty easy. Just take these two numbers and divide it. So y is -2. Okay, and then once we're here, we're going to use this value to figure out what the x value is going to be. So again, you pick any one of the equations. Since we were just using these two, let's pick one of these two. Last time we used equation 1. This time we'll pick equation 2. And it doesn't matter if we pick this equation 2 where we multiply by -1, or we pick this original equation 2. As long as we pick any one of these equations that's got an x and a y, we're good to go. Doesn't matter if it's this one or this one or this one. So just, kind of pick one and see what we get here. So for this one, I'm just going to use this equation 2 that's right here. So that's -3x minus 6y equals 8. Again, we're going to plug in -2 right there. All right, so that's -3x. That's going to be a plus 12 equals 8. We're going to subtract 12. All right, and at the end, somebody's going to say, well, hey, wait, because that's not a whole number. No, it's not. Because we're going to divide by -3. That means x is going to be a positive 4/3. If you happen to get a fraction answer, leave the answer as a fraction as much as you can simplify. You don't have to rewrite it as 1.3 because technically that's not 1.3, it'd be 1.3 repeating. So in most cases, they're going to tell you just leave the answer in fraction form. If it happens to be 4/3 or 19/12 or something like that, just leave it that way and then we should be fine. So as an ordered pair, that would be 4/3 and -2. Okay. And again, they may ask for different, and if they ask for just each individual number, we already can plug in the value for y, and then we've got the value for x, but as an ordered pair, that's our answer we're looking for here. All right, everybody good there? Everybody feeling okay? I got a question, maybe? Well, and that's what we'll do tomorrow, is that basically we would take this equation, rewrite it in y equals mx plus b form, take that equation, rewrite it in y equals mx plus b form, and then you graph those two lines to tell you where it would be. Now, then that's kind of the bad thing about graphing is that, can you tell me exactly where the point 4/3 is? No, right? Because at that point, it's just going to be a good guess about where you think it is. So that's why to me solving is the better option, because we can solve it until it's exactly 4/3. If you graph it, you can go, well, it's somewhere around this point, but you can't quite get there. This one was okay because this first one back here, the order pair was at 4-0. That would be an easy one to solve and graph because it's a 4-0. If you get any kind of decimal number, it's probably going to be really hard to do that unless they have it that the graph is broken up into thirds. So it's 1/3 and 2/3 and 3/3 on the scale as you're going through. But probably most of them aren't going to be that way. So we'll show you that one tomorrow because that's the bad part about graphics. Yes.
So it doesn't matter if you plug it into the x equals y in the equation?
Well, it just depends on what you get first. Like on this equation back here, we got x first, so we had to plug that into x. This equation, when we solved it, we had y. So we had to just take that and plug it back into y. So it just depends on which one you solve for first. So there's no right or wrong way really to which one you get. Question? Oh, because in that case, it was a -3 we're dividing by. So it's -4 divided by -3, the two negatives, then make that a positive. All right, any other thoughts? Okay, now here's where we're going to bring it up just one little notch here. So we'll go 3x plus 2y equals 6, and then 6x plus 5y equals 12. Okay, now here's where you have to kind of ask yourself. Here's where it gets a little bit more difficult because if we look at this one, we don't have the same numbers on the same variables. All the numbers are different. So that's not so now we got to rework this thing around. Now we got to start multiplying some numbers to see what we can do. And if you get to this point where none of the numbers match up, basically is this. You look at the smallest numbers you have here on the variables, like we've got 3 and 6 here, and we've got 2 and 5. And the first thing you want to say is, okay, is there a number I can multiply to go from 2 to 5 on the y? A whole number. I mean, we can get decimal numbers, but no. All right. Can we go from 3 to 6? Multiply by 2, right? So we know on this equation on the top, if we multiply it by 2, we're going to have 6x and 6x. But if we multiply this one by 2, they're both going to be positive, right? So if this one's already positive, 6x, and we're going to multiply this one by 2, let's just go ahead and multiply it by -2. And that way, if we multiply it by -2, it's -6x, and this one's already positive 6x, so then we go there. Okay, so that's one where you can kind of do both steps at the same time because some people are like, what if I multiply it by 2 and I've got 6x plus, 4y equals 12 and I forget my negative? Well, then you're going to have to go back and multiply one equation by negative. You just have to have an extra step there. So it's one of those where if you can kind of think about it ahead of time, you can get your numbers to match up and all right, I'm going to multiply by 2, so I've got 6 and 6. If they're both positive, if we're multiplying this one by 2, let's just go ahead and take the next step and multiply it by negative, so now it's a -6 and a +6. Okay, so that's going to give us multiply equation 1 by 2. That's going to be -6x minus 4y. Here's where you got to be careful so you don't get in too big a hurry. Because usually if I make mistakes, it's with those negatives. I'll forget one. So we got -6, -4, -12. Okay, so that looks good. So now we've got 6x plus 5y equals 12. Okay, and again, we've got +6 and -6, so we're good to go here. Just add these two things together. That's going to go to 0, which is what we want. So it's gone. We've got -4 plus 5 or 5 minus 4, so that's 1, or just y equals 0. Okay, and then we're halfway there. Okay, and again, pick either one of the equations. Doesn't matter if it's equation 1 or equation 2. Just pick a number, plug it back in. I won't go with equation 2 just because it looks a little better to me. Again, doesn't matter if you pick equation 1 or equation 2. Either way is fine. So that's 6x plus 0 equals 12. Which again, if it's 0, it doesn't really do anything to it. So that's just 6x equals 12. Divide both sides by 6, and we get x equals 2. Okay, so order pair answer 2, 0. Okay, so again, if the numbers don't match up, just look to see if you can multiply one equation by another equation. And really what it comes down to on those is, if it was 3 and 6, those are multiples or factors of each other. If you see one that's either multiples or factors of each other, depending on whether you look biggest or smallest to biggest, that's one you want to key on. 2 and 5, they're not factors or multiples of each other, but 3 and 6, they're, 6 is a multiple of 3, 3 is a factor of 6, ever how you want to look at it. That's kind of the ones you want to key on. All right, for the last one, this is a worst case scenario. But even then, once you see the trick to it, you go, well, that's not too bad. So let's go negative 4x minus 3y equals 5, and then 3x minus 2y equals negative 8. Okay, we don't have the correct numbers, so we know we've got to do some multiplying here because we've got 4 and 3 here, and we've got 3 and 2 here. So the numbers don't match up. Is there any easy way to multiply to get from 2 to 3? No. I mean, we can use a decimal number, but we don't do that. Same thing with 3 and 4, right? There's nothing we can multiply to go from 3 to 4. So you're always looking for smallest to biggest. There we go. So Josiah's got there. We're going to multiply the top and the bottom by some numbers because if the numbers don't match up, we're going to multiply both rows. Okay, and you can do this a couple of different ways. I always like to do it this way. Is I'm going to take the first two numbers that we have here for x, or whatever the numbers happen to be on the left. Sometimes they'll put y's there, but most of the time it's going to be your x's. And you're just basically going to take this equation, the 4, and you're going to multiply this equation by 4. And you're going to multiply this equation by 3. Because now you get 3 times 4, which is 12, and you get 4 times 3, which is 12. So you just flip-flop the two numbers. And if we'd done the same thing with the y's, we could have done the same thing here. We could have taken this row, put the 2 up here, taken this 3, put it down here. So we can multiply this row by 2 and this row by 3, so we get 6 and 6. Depends on the signs, and that's what we're going to check and see. So. Okay, and that's the only thing you have to kind of check. Sometimes you might need a negative, sometimes you don't. It just depends on the numbers when you go through these. So I always kind of do this first. Is I'll go ahead and multiply. I guess here's the thing. If one's already negative and one's already positive, then we can use, we don't have to worry about taking these signs out here. We can just do a 3 and a 4. If they're both negative or they're both positive, you're going to have to change one of these. But I always tell people, just look at it first. Go ahead and multiply the top equation first. So we've got 3 times 4 would be negative 12. 3 times negative 3 is negative 9. And 3 times 5 is 15. Okay, so if we know the top one's negative, the bottom one's got to be positive. So if we get to this one and it's not positive, we might need to change the sign. But if we do 4 times 3 and it's 12x, it's already positive, so we're good to go. Oh, if we did make that a negative, this would be negative 12, right? And we were saying if you're going to do that, you need one of them to be positive and one of them to be negative. And so if they're both negative, then you're going to have to go back through and multiply by another negative again. So it's kind of one of those things of just take out the numbers first. And if the numbers work out like we took out just the 3 and the 4, that if you take out the numbers and it works out that they're positive, negative, then you're good to go. If they're both positive, then you know you got to make one of them negative. So just got to kind of take a little piece at a time on that and see.
So like for adding the equations and one is negative and one's, oh, they're both positive, then you multiply by negative, but like for when you're multiplying the equations, then you just do it each time? Or can you ever multiply a negative?
You can.
Like add
It depends on the numbers. Like if both of these had been negative numbers over here, and we just pulled out the 3 and the 4, if we multiplied this by, let's say just for a minute, if this had been negative, we had 3 times negative 4 would have been negative 12. This was 4 times 3, it would have been negative 12. That if you get here and you go, wait a minute, I need one of those to be negative, I need one of those to be positive. That's when you know you need to change this sign so that if we do a negative times negative, it would make that a positive. So you just have to kind of take it one problem at a time, because sometimes you might need a negative and sometimes you don't. It just depends on how the signs match up. So
like sometimes when we add the equations and like we multiply it by -1, we don't do that for the multiplying.
You can. It just depends on the signs of how they're there. So
Okay.
yeah. So there's not a. I mean, there is a rule, but it's more one of those things. If you just kind of get to the end and look at it, and see what you need on those, then that's kind of the thing you want to do. But I guess the big thing is if one of these is negative and one of these is positive, you don't have to worry about taking these signs out. You can take out just the numbers. If they're both negative or both positive, then you got to change the signs of one of the numbers. If you want to kind of make that a rule. But okay, and we'll do another one of those here in a minute just to make sure we got it. So, all right, so 4 times -2 is -8. And then 4 times -8 is -32. Okay, and if you do this and the signs happen to be wrong, just go back and multiply one equation back by -1 again, and then you're still okay. Because multiplying by -1 is about the easiest thing that you'll do when we're multiplying by equations. So. Usually it should just be twice, because you do the first row and the second row, kind of swap them at the same time. And some people may get to the end, they go, well, they're both positive, so I need to multiply one of them by negative. So you might have to do that just for that one extra spot there. All right, Josiah, here you go. I try to bring in some little treats along the way, so if somebody has a good question or a good thought or a, hey, I know what's going on here, and then give it to me, and then we'll toss you a Starburst. So keeps everybody, that way if keeps you on top of your toes a little bit. All right, so from here, let's just go ahead and solve it. Add them together. So that's 0. That's what we want. It's gone. -17y equals -17. All right. Divide those two to get y equals 1. All right. Now, if I'm going to plug in the numbers, I don't want the numbers to be bigger because we multiplied everything here. I'm going to go back to these where it's smaller, just because to me it seems like it would be a little bit easier. And again, it doesn't really matter. You should get the same answer either way. If I'm plugging this in for y, I want my x to be positive, so I'm going to use equation 2 back up here. So that's 3x minus 2y equals -8. Plugging in the 1. That's 3x minus 2 equals -8. Add 2 to both sides. And then finally we get to divide by 3 here, so then x would equal -2. Okay, so order pair answer, -2, 1. Again, they probably, if it's Math Excel, they'll probably give you blanks for each of those, so you don't necessarily have to put it in order pair.
Can you move this sheet up a little bit?
Mm-hmm. Okay, so that's elimination. That's everything that you can kind of see. And again, that's about as bad a problem as you can get with elimination, where you have to multiply both equations by some non-zero number to help you get there. It's not going to happen every time, but it's probably one of those, depending on how it gets there. It's anywhere from 25% to half the time, somewhere in that ballpark. Maybe a third of the time you have to do that. Okay, to me, and of the two options we're going to do here today, I think to me that's the easiest one, just because the math is easier. There's a second option that we're going to show you. And it's more one of those that just making sure you have it, because when you get to pre-count, sometimes there's problems that you want to do with the addition or the elimination method with it because it's going to make work easier. There's other times when you have to do substitution. You don't have to, but if you did elimination method with it, it would make your work about 10 times longer. So as long as you've kind of seen both and are familiar with both of them, then we'll show you that one, because when you get to pre-cal, sometimes there are times when it's easier to do it one way than it is another way. So it's just a matter of keeping up with it. Okay, so for the second one, we're going to solve by substitution. And this one's a little bit tougher because when the first step of it is, well, actually it's the first step. Doing the back ones back here when we were doing elimination, usually the first step was usually really easy. And the second step was the one that was a little bit longer because you had to take the number and you had to plug it back in. Substitution is probably the opposite. The first step is the longer step, and the second step is like really quick. Let me go through these. Or the first variable, getting the first variable is the long part. Getting the second variable is like really quick just because of the way this one's set up. All right, step one for this one, because it's more of a three-step kind of system. You've got to get one variable. I'm sorry, let's get one equation. Solve for one variable. If they don't have it this way, usually you want to pick the variable that has coefficient of 1. Now, not necessarily every time, but almost all the cases we'll say usually. Usually that means pick the variable with a coefficient of 1. That's usually your default you want to go to. That's usually going to be the easiest equation to solve for either X or Y, depending on how it is. Sometimes they already have step 1 done for you. Sometimes they don't. So it just kind of depends on the problem that you get. Okay, so if you can get one equation solved for one variable, then what you're going to do, here's the substitution part. You're going to substitute the equation from step 1 into the, and this is usually the best way I've been able to come up with it. We're going to say into the unused equation. Because to do step 1, you're only going to pick one of the two equations. To do the substitution, you're going to then substitute that answer into the equation you haven't used yet. Okay, if you do that, you should only have one variable left, so you're going to solve for the remaining variable. Whether that's X or Y, it doesn't really matter which one it is, kind of like we did last time. It doesn't matter if it's X first or Y first, that's fine. You find out what that variable is, that value, and then you're going to plug that back in. Then you're going to do like we did before. You're going to use that first variable value to find the second variable. Okay. So, and again, that third step is always like the easiest one because once you get x equals 2, you're just plugging it back into an equation and that's easy to go. Okay, here's the shortcut for this one too when you get to step 3. To make it go really fast and really easy, use the equation from step 1. Because that's going to make the work go a lot faster because once you've done the work in step 1, we're going to reuse that one just over and over and over when we go through those. Okay, and we'll do just like we did last time. We'll start with one that's kind of easy and set up for you, and then we move to one that gets a little bit tougher as we move along. Okay, so we'll go 3x plus 4y equals 12, and then y equals negative 2x plus 10. Mm-hmm. Yep. So just say solve. And again, it may say solve the system, but it's still just basically going to say solve. Okay, since this one already has y equals negative 2x plus 10, then basically this part's done. So equation 2 has y equals, so step 1 is already done. Okay, so that's the step 1 says you got to get either x equals something or you have to have y equals something. That's when you get the variable by itself. So if you already have that, step 1's done. So now we're going to take this y equals that we've got here, this negative 2x plus 10, and we're going to plug this into equation 2. Sorry. So we're going to plug that into equation 1. So we got 3x plus 4y equals 12. All right, and again, we know y is the same thing as negative 2x plus 10. So this has to go in for y in the other equation. Okay. And to me, that's the part that makes this one a little bit more difficult is that now you've got to do distributive property, and we didn't have to do it the other way. So this is the part that makes this one, a little bit tougher. You have to worry about more signs with this one, the positives and the negatives, and it's just got a little bit more work to it. So to me, it's always one of those things of, if I can avoid doing substitution, sometimes it's set up and it goes a lot faster. Like in this case, it actually goes pretty fast. Other times, it doesn't go quite as fast. All right, so we got 3x. We're going to do 4 times negative 8, so that's going to be negative 8x, and then 4 times 10 is 40. Equals 12. All right, here's why we worked on that first few days and worked on solving equations, because now we got 3x minus 8x. This is on the same side, so go ahead and put those two together and make it negative 5x plus 40 equals 12. And then we can subtract 40 from both sides. So we negative 28. Okay, we're not going to get a whole number here. We're going to divide both sides by negative 5. So that's going to be a negative over negative. It's going to make that 28 over 5. Now, in that case, they'll probably let you write that as a decimal number because that actually comes out to be a nice decimal number. It's not a repeating number. It's not 1.9743. It's just 5.6. So if it's a stopping, pretty easy decimal number, they may let you just stop with that. And this is one of those problems. If you were doing Math Excel and you got to this one and you had a decimal number, that's probably where I'd click on the show me an example, because then it should have you one that's got a decimal number in it also. And then you can go back and see, did they leave it, did they use 28/5 or did they use 5.6? And they should be able to kind of tell you which one they're going to use there. Okay, so we've got the 5.6. And again, you can pick any equation we've done so far, but if we keep reusing this same equation that's here, this will go a whole lot faster, because we've got y equals negative 2x plus 10. And since x is 5.6, we plug in the 5.6, it goes right there. And that way, to plug it in, it's really, 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 really easy, because then it's just, you'll multiply it by negative 2, and then you're going to add 10. Okay, so you're going to take what you have from step 1 and use that to plug in to find out this one, and then use that same equation from step 1 to take this number and plug it back in. Now, again, you could pick, this equation and still get the same answer, but this one, if you use that same equation we did back in step 1, it's going to get you the answer a lot faster, because everything's set up so you can plug in numbers and get the answer you need really quick. Okay. And again, to me, this is not the best option, just because it's just not the best option. But in that case, if you already have one that already has y equals or x equals, it usually goes pretty quick, just because it's set up to kind of do that when you get through this. All right, now let me show you one just in case you would do this, just to show you how it would look. But you don't have to do it this way. But I just want to show you one that just in case here. I think this is our last one today. Yeah, it's the last one today. Oops, you can see it, right? There we go. Okay, now, again, if they tell you to solve by substitution, honestly, if it was me in this case, I would not do substitution. I would do elimination, because everything is lined up, right? So if it was me, and again, if I'm just doing this and nobody's going to see the work, if I'm doing ACT and nobody's going to see my work, and I know what it just says to solve it by substitution, I'm really not going to do it. I'm just going to take this top row and multiply it by 2, because then I've got 2x and negative 2x, and then boom, I've got elimination done, and I'm good to go. Okay, but let's just say that some things might have you, because there's sometimes where they will make you do like some in-between steps. So we're going to go ahead and do this one by substitution, just to show you what it should look like. If you're just doing these to get an answer, you can really pick either way, but we just want to show you what they look like. All right, so this one does not have an x equals or y equals, but you do have this coefficient of 1 in equation 1. So we're going to solve equation 1 for x. So if it's x plus 3y equals 5, just one thing to get x by itself, we're just going to subtract 3y from both sides. So we got x would equal negative 3y plus 5. And somebody's asking, does it matter if we do negative 3y plus 5, or could we do 5 minus 3? Either way is fine. Doesn't matter, as long as you've got the x by itself. That's the main thing. All right, so if this came out of equation 1, we've got to plug it into equation 2. And to me, it always helps to write down an equation just so we can see what we're doing. So we're going to plug that into negative 2x minus 4y equals negative 8. So wherever we've got x, we're going to take this whole thing out and plug it in right here. All right, so that's negative 2 times negative 3y plus 5 minus 4y equals negative 8. All right, so then we're going to multiply everything by negative 2, so that's going to make that a positive 6y, make that a negative 10, minus 4y equals negative 8. All right, and again, here's where you got options of how you want to solve this. When we've got the 2y's over here, we've got the number. If you want to go ahead and do the plus 10 and move it over here to the side, that's fine. That'll leave you with 6y minus 4y equals 2. And if you have 6y minus 4y on the left-hand side, just keep it together and just make that 2y equals 2. So then we get y equals 1. All right. And again, you can pick any equation to plug it into, but this equation from step 1 back here is going to be the easiest one. So let's plug this into x equals negative 3y plus 5. Okay, so we're going to take that y equals 1 and plug it in here. So we're going to take out the y, plug in the 1. So x equals negative 3 times 1 plus 5. That's negative 3 plus 5, so x equals 2. Okay. So of the two, most people, whenever we've done these in the past, most people go, I don't like substitution so much. And I understand why, because it's the math is a little bit more involved. You know, when you're doing substitution, math's a little bit easier. So I understand to go that route to kind of get to where we're going. But again, either way is fine. You could just how we took this equation that was set up for elimination and we rewrote it with substitution to solve it. You know, you could even have taken this equation we had back here for equation. We could have taken this one, because sometimes, let's say you're doing a problem like this and you're like, okay, I don't really want to do substitution. You could take this 2x and you could add 2x to the side and add 2x to this side, and then you could do elimination. And sometimes they may make you do that. They make you take something like this and tell you they're going to do elimination. And if you do elimination, you got to make sure that your x's are lined up, your y's are lined up, your equal sign is lined up, and your number sign is lined up. If they're not, you've got to rearrange them so that everything lines up so you can solve it. So you can really do either one, either way. It's just sometimes you need to practice for some, and sometimes you need to practice for others. Because again, when you get to pre-cal, there's some equations that are a lot easier to do with substitution than there are elimination, and then there's other equations it's a lot easier to use elimination than there is substitution. So we're just going to have to be able to use both when it comes down to it. All right.